This is Honors Algebra 2 Pre-Calculus. We're doing homework review for section 10.2 in Pre-Calc, number 17 on page 772. So let me start off with an apology. I didn't do an example of this because I didn't actually intend to ask you this question, and I think it's one of those things that you definitely do not have to have memorized and should just be able to apply. I don't know that I've ever actually seen this particular problem in my life because it's not a thing I normally address when we do 10.2, and it's not a skill that I particularly think you'll need. But I did ask this question by accident, so I apologize, and I'm going to walk you through it. So there's a very similar example to this on page 710 of your textbook, right? So if you look at, in the text, example 4 on page 711, you'll see a really similar example to this. So if what I'm doing doesn't jive, take a look at that example. I will be 100% honest and say that I definitely looked at that example before doing this problem. There's also some useful info that you need in order to do it on page 710, and we're going to walk through that now. But just so you know, again, totally accidental, didn't mean to give you this particular problem, and if I did mean to give it to you, I would have given you an example of this in the section originally. So totally mea culpa, right? That's my bad in Latin. I'm sorry. So the property that we're going to use to do this is actually listed on page 710, and what it says is the reflexive property of a parabola. The tangent line to a parabola at point P makes equal angles with the following two lines. The line passing through P and the focus of the parabola, and also the axis of the parabola. So let's walk through what this looks like. So let's start with this parabola right here. The parabola that we're given, because it doesn't have like an x minus h quantity squared or a y minus k, that must mean that the center is 0, 0, right? So this is a parabola that has center at 0, 0. Because it's an x squared with a negative p, this is a frown. So this is the formula x squared equals 4py, right? Where in this situation, 4p is negative 2, so my p must be a negative 1/2. So the situation I'm looking at right now is a parabola that looks like this. It's got its center at 0, 0. Sorry, I didn't mean center, meant vertex, man. It's been a long day. Sorry, meant vertex, long day. So it's got its vertex here, right? And then I'm not drawing any scale here, but the focus right here is going to happen 1/2 unit below the center. So the focus is going to be 0, negative 1/2. So here's what they're trying to say. If that's a half, we're going to make this 1. So I did a terrible job of drawing this, but you get the gist. So if that's 2 out, right? So somewhere down here, and again, I'm going to do a terrible job of drawing this, but at 2, negative 2, we're supposed to have, that's going to be a point on my parabola. And again, terrible job drawing it, but you get the gist. Okay, so this is what they're trying to say on 710. What they're saying is the tangent line. So a tangent line is something we do a lot in calculus, but we really don't address very much in pre-calc. A tangent line glances next to the curve. It's the same idea as when you look at a tangent on a circle, right? So a tangent on a circle is a line that touches the circle once, just on the edge, right? That's a tangent line, or there could be a tangent line here or here, right? If you were to fly off a roller coaster because your car accidentally broke and you go flying off, you're going to fly off tangentially. It is only gravity that makes you stop traveling in a straight line. So this tangent line, based on what they say in 710, if you draw this tangent line, and this is not to scale, so you're just going to have to forgive me, okay? If you draw this tangent line, so it's my tangent line at the point 2, negative 2, which is the point they gave me, right? It's going to make equal angles, so it's going to basically create a triangle, right? That if you draw the triangle from point P to the focus, and then also draw the line from the focus to wherever this intersection is at the axis, this angle has to equal this angle. So what that means is that it inadvertently creates, so that's what we get from page 710, right? What that does is creates an isosceles triangle. So essentially these two distances have to be the same. So we actually can find the distance from the focus to P because we know both of those points. And this distance, let's call this y-intercept 0, b, because in y equals mx plus b, we use b for the y-intercept. This distance is going to be b plus 1/2, because we already know that the y-coordinate of this piece is negative 1/2. So essentially, if we call this guy distance 1 and we call this guy distance 2, we know the two of them are equal. So we know that distance 1 is b plus 1/2. And we know that distance 2, if we use the distance formula between the focus and point P, we can find a quantity for distance 2. So that's going to be 2 minus 0 quantity squared plus negative 2 minus a negative 1/2, which would be plus 1/2 quantity squared, So that's going to end up being a 4 plus, this is a 3/2 squared, so that'll be a 9/4. Well, that, if you get a common denominator, this is a 16/4. Sorry, guys. This is a 16/4 plus a 9/4. So that's a square root of 25/4, which is 5/2. Well, if you know that both distances are the same and that this distance is 5/2, you can find b. You know that b plus 1/2 is 5/2, right? So based on that information, if I slide over here for a sec, I now know that b is a 2, right? 4/2. So here's why that's useful. This tangent line right here, right, this thing that I originally drew in red, but I'm going to line out in green now. If I want an equation for a line, I just need 2 points. Well, I now know that the y-intercept is 0, 2, and I know that it has to pass through point P, which is 2, -2. As long as I have 2 points, I have enough information to find the equation of that line. So if I give myself some room, the equation of that line, right, is going to be, I'll switch to a better color that you can see, right? So the equation of the tangent line, which goes through both the 2, -2, which was point P, and the y-intercept of 0, 2, well, I can find that slope by doing y minus the y value, so -2 minus 2, over x minus the x value, which is 2 minus 0. I get a -4 over 2, so the slope's a -2, and I already know the y-intercept. So the tangent line equation is y equals -2x plus 2. And in this case, I actually wouldn't bother to do point slope because you know the y-intercept already. They then asked me what's the x-intercept of that. Well, x-intercept just means that you plug in y as 0. So 0 equals -2x plus 2. 2 equals 2x. X is 1. So they asked for the x-intercept. It's 1, 0. Right, so again, totally my bad on this. So this is my x-intercept, right, 1, 0. This is my equation, y equals -2x plus 2. Honestly, I have never done this problem before in my life, and I've used this book for years. It's never been a thing that I think you especially need to know how to do. We'll do a ton of tangent line stuff in calc, and the other reason I think it's kind of funny is that I could do this question way faster with calculus. Like, I could do this in my head with calculus, and I can't do it in my head this way. So, kind of the reason that I point out that this is a skill you don't necessarily need is you're going to have a way better way to do this in maybe 4 months. So while right now this looks kind of complicated and awful, this is I can do it quickly in my head problem in calc. You just don't have the skill set yet.